Now we are going to discuss common emitter amplifier. Common emitter amplifier, we have got biasing circuits, input capacitor, coupling capacitor, emitter bypass capacitor. So we can just see the circuit diagram given. We have got a transistor. As for all the circuits, we connect a resistance at the collector, which is RC, and we have got a resistance RE connected at the emitter. Then plus VCC gives the supply, and for providing the biasing, connected R1 and R2, which is connected in order to provide voltage divider by. So R1, R2 is connected to the transistor. Then we have got the signal to be amplified, and that is given to the input of the transistor through a input capacitor Cin. The role of emitter bypass capacitor. So what is the purpose of connecting this emitter capacitor Ce in the circuit of a common? That's what we are going to see here. So the main purpose is to increase the gain of the amplifier. So how does it increase? Connecting a amplifier. As we have told in the previous, resistances R2, and which is connected at the is basically stabilization of the circuit. Now, when we are applying an AC signal to this amplifier circuit, AC current will flow through this RC and RE. RC is the resistance connected and RE is the resistance connected at the emitter. So, when current flows through this emitter resistance RE, it will develop a variable voltage drop across RE apart from the drop due to DC current. So, it provides a negative feedback to the emitter junction, which will reduce the overall amplifier. Now, by connecting a capacitor Ce across Re, we have a short circuit path or a path which has got low resistance than this path containing resistance Re for the current to flow. So, obviously, as we all know, the current will always take the low resistance path. So, when we are providing two paths, a path which contains resistance Re and another path which contains capacitor Ce, the current will definitely flow through this capacitor Ce. That will provide a short circuit path for the AC signal and reduce the effect of additional negative feedback due to AC signal through Re. Thus, it increases the gain of the amplifier. Connecting this capacitor E, we are providing a path, a short circuit path or a low resistance path for the AC signal to flow to the ground. So, we are preventing the voltage drop that may occur across Re, and thus eliminating the reduction in negative feedback and thus increasing the gain of the amplifier. So simply we are bypassing the current through a path which contains capacitor rather than flowing it through a path containing resistance. So here we are bypassing the current flow. That is why it is known as emitter bypass capacitor. Now we have got capacitors, one at and the other one at the output side. So now we can see what is the role of those coupling capacitors. So at the input side, we have connected a coupling capacitor which has C in. So the main role of this C in is to couple the AC signal to the transistor input. So in a common emitter amplifier, the transistor input is base terminal, and another duty is to decouple or block the DC component contained in the input signal of the amplifier. So it's DC component, and that's why it is known as blocking capacitor. Now we are getting another coupling capacitor at the output side also, which has CC, and the duty of this coupling capacitor at the output side, that is CC, is to eliminate the DC component introduced during the amplification. So, and we have connected a resistance RL at the terminal. Resistance connected across the output terminal is also called load resistance RL.